Hi, my name's John. I'm going to be going over some geometry stuff with you today regarding transformations. This is one of the chapter headings that you're going to be doing, and specifically we're going to do rotations and reflections. Transformations are three types of transformations involved. One is rotation, where you're actually moving things around from here to here like this. That's called rotation. A reflection is something that gets reflected or mirrored. And then a glide or slide, they call it translation. I'm not going to be doing a lot of translation right now. Some of you will hear the word isometry. Isometry is all of the parts are going to be congruent. So isometry is a little bit different. We're not going to be talking about isometries today. But basically a translation is an isometry. Okay? So that's some information that you should know. Let's go this a little bit closer together, and then we're going to go look at some information set. Rotation of 90 degrees, half rotation, rotation about negative 90 degrees, rotation about a certain point, reflection about the x-axis, y-axis, and the line y equals x. Okay, so we're going to put on our hat. This was supposed to be a hat, magic hat. With a bunny in it, but didn't come out so well. I don't know what happened. Doesn't really matter. We're going to put a different hat. It's called the scientific hat. The scientific hat says that first you make an observation, and then from your observation you make a hypothesis, and then you test your hypothesis, and then you make a conclusion, and that's basic concept of the scientific hat, right? Or a scientific method. You could do double placebo blind tests. I'm not sure if you've ever heard of that. You'll hear of that maybe in college when you take psychology or any type of science courses. So let's get started with it going. We're going to do a rotation about the origin 90 degrees, and we again I'm going to write this again. It's called a rotation about the origin 90 degrees. And the way we do that is, here's the first quadrant, second, third, and fourth quadrant. You should all know that by now. A rotation of this direction counterclockwise is positive. So I'm going to write this down. Counterclockwise is going to be positive rotation, and then clockwise is obviously going to be negative rotation in degrees. I'm going to do a 90-degree rotation. So I'm going to pick a point. Let's pick the point 4, 2. Let's call that P right there. So there's a point P called 4, 2. I'm going to label that 4, 2 right there. And we're going to try to rotate this image about the origin 90 degrees. And one of my students said, oh, it should be somewhere around here. And if a good way to show that it's not in the first quadrant is you can draw a line to the origin right here. Notice if it gets rotated 90 degrees, it's going to turn up maybe somewhere here. That seems to be about 90 degrees. So we're going to try to guesstimate. We're going to use our scientific hat. We're going to make some observations, okay? It seems to be like it probably went to the left 2 and up 4. So I'm going to use a little bit different marker for this. I'm going to use orange. It's going to be -2, up 4. 1, 2, 3, 4. Does that seem to be a 90-degree rotation? It seems to be a 90-degree rotation right here. So we're going to call this the image P prime. It's going to be -2, up 4. So let's see what happened. And I'm going to use a different nice pen for you. So 4, 2 got rotated about 90 degrees, became -2, 4. So what happened here? Point x, y, you notice that these got changed, the x and y got changed, and on the new x it became negative. So I want you to pause in a couple seconds, press the pause button to try to figure out what happened in the xy coordinates. So we're going to make a hypothesis. And our hypothesis is going to be x comma y gets rotated about the origin 90 degrees, and what happened in your xy value. I'll pause it right now, just try to figure out what would happen. Okay, 1, 2, okay. So what happened here was the x and y got switched, so it became y comma x, and the new x, it became negative. So it's got a negative y comma x. That's our hypothesis. Now, the scientific method says that we should verify our results using a different set of points. So let's try and pick maybe a third quadrant point and then rotate it 90 degrees this way to quadrant 4. So let's pick one, negative 1 comma negative 2 comma negative 5. That's a good one right there. So let's call this J right there as negative 2 comma negative 5. So there's that point. So we're going to test our hypothesis. Negative 2 comma negative 5. We're going to rotate that 90 from the origin 90 degrees right here. And what happened? We flipped the x and the y. Became negative 5 and negative 2. We flipped it. We changed the sign on the new x coordinate. Should be 5 comma 2. So I'm going to use pink for this. Positive 5, 1, 2, 3, 4, 5, and then negative 2 right over here. And let's see, I'm going to extend it out from my origin right there. I'm going to extend the old one from my origin. There it is. Does it look like it got moved 90 degrees? Yes. So we tested our hypothesis. It worked very nice. So that's, in conclusion, rotation of 90 degrees about the origin is going to be from x comma y. Flip it, change the sign on the new x. Okay? I would memorize this. If you memorize this right here, then the next one will be pretty simple to derive. So let's do the rotation about negative 90 degrees. Rotation about the origin of negative 90 degrees. Let's see what happens here. Our original statement says that if we rotate it about 90, we flip the x and the y and we change the sign on the y. So let's make a new hypothesis from here. We're going to create a point, x comma y. We're going to rotate it about the origin, negative 90 degrees. And I want you to think about what your new hypothesis would be in this situation. Put on your scientific hat, press the pause button if you have to, and try to figure out if it's a positive rotation, we flipped it, change the sign on our new x. What do you think is going to happen when we rotate it negative 90 degrees? Think about that. 3, 2, 1. Hopefully you press the pause button and then restart it. It seems to be that the x and y are changed again. So it's going to be y and x. And this time, instead of putting a negative on the new x, or y in the case, should be negative. Let's test our hypothesis. Okay? We can pick a third quadrant, and if you rotate it about the origin, negative 90 degrees, it should land somewhere on quadrant 1. Or we can pick quadrant 3, it should go to quadrant 2. Of course, quadrant 4, then it should go to quadrant 3, of course. Okay, so let's pick one here. Let's go negative 4, negative 5. Negative 4 comma 5. There it is. Negative 4 comma 5. And let's call this K. So what should be the image when we pick negative 4 comma 5 and we rotate it about the origin, negative 90 degrees. We flip the x and the y, 5, negative 4, and now we change the sign on the new y value. So let's, before we do that, we're going to check it about the origin right there. There's a distance right there, whatever that point is, extended from the origin, okay? I'm going to rotate it negative 90 degrees. It should be 5 comma 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. And here it is. Does it look like it got rotated 90 degrees? It seems to be the case. that if you actually physically work it out, this point got, and we're going to call this K prime right there. That's the image. Okay, hopefully all of you can see that. So K, the pre-image, got rotated about K prime, the image, of negative 90 degrees. And it seems to have worked, so that's our hypothesis, and it's a pretty good rule. So once you understand a clockwise rotation from here, excuse me, x comma y to negative y comma x, it should become apparent that as you flip the x in the y coordinate, the negative became went on the new y value. Okay, so let's do a half rotation. And what we're going to do, there's several ways to do this. I could actually start with an observation, the scientific method of the observation, and then work it out. Or I can use the mathematics part of it, and I've actually done it both ways with both students. Let's actually use the scientific method, okay? Let's make an observation. Let's say the coordinate of this point right here, we're going to pick a quadrant in the second, -3, -5, -3 comma 5, -3, 1, 2, 3, 4, 5, there it is right there. Let's call this point, I don't know, A. So what we're going to try to do is we're going to rotate it about the origin. There it is, 180 degrees. If you rotate it, it doesn't matter if it's a half turn, half rotation is equal to 180 degrees clockwise, or which is equal to negative 180 degrees clockwise, counterclockwise. Sorry, let's say that again. This one will be a counterclockwise rotation. This will be a clockwise rotation. Just want to make sure. So if you rotate it clockwise or counterclockwise, it doesn't really matter. We should end up with something in the fourth quadrant. If you kind of extend this out, I'm going to use green this time. Got lots of different markers. Seems to be went up 5 to the left 4, or left 3, so it's going to go right 3 and maybe down 5. So here's your point right there. Seems to be a 180 degree rotation. That doesn't work very well, so I'm going to use my orange. There it is. 180 degree rotation. Okay. So that point A prime, that's called the image, should be -3 comma -5. This is what actually happened. The x value didn't change, it just changed sign. The y value, so our observation says our y value didn't change, it just changed the sign. So let's look at our hypothesis. And now I want you to figure out what your hypothesis would be if you did a half turn about the origin. So HO stands for a half turn about the origin. A lot of books, you call a rotation about the origin 180 degrees. Another word for that is a half turn, right? And let's see what would happen. Think about that for a little second. The x comma y became negative x, negative y. We're going to test our hypothesis again. We're going to pick a point.